Good afternoon. I am Chauhan Hardik, working as an assistant professor in Mechanical Engineering Department at Atmi University. On behalf of Atmi University, I welcome you all for this video lecture series. Today we are talking about the elements of mechanical engineering subject, which is commonly used in all the branches. So we are starting the first topic of our session, that is prime mover. It is a device which converts the natural source of energy into mechanical work. The examples of prime movers are wind turbine, steam turbine, water turbine, IC engine. The prime movers uses the various sources of energy like a fuel, water, atom, biomass, wind energy, and so on. The classification of prime mover are thermal and non-thermal. Thermal prime mover, which are related with the heat, and non-thermal prime mover, which are not related to the heat. In thermal prime mover, the classifications are fuel, nuclear energy, geothermal energy, bioenergy, and solar energy. Whereas in non-thermal side, the hydel energy or hydro energy, tidal energy, and wind energy. Again, fuel. Fuel is a mixture of carbon and hydrogen, burns in the presence of oxygen, then it releases some amount of heat. So related to fuel, some classifications are there, which is of external combustion and internal combustion. External combustion is that the combustion of fuel take place outside the engine cylinder is a external combustion engines, and the combustion of fuel take place inside the cylinder are of internal combustion engines. In the external combustion engine, the steam engine, steam turbine, and closed cycle gas turbines are there, where in the internal combustion engine there are all types of IC engine and open cycle gas turbine. Move forward. These all are the non-thermal cycles: hydro energy, wind energy, and tidal energy. Now some of the basic definitions are: mass. It is a quantity of matter and its unit is in kg. Right? Weight. Weight is a force exerted by a gravity. The unit of weight is Newton. Weight is equal to the mass into gravitational acceleration. W is equal to m into g. G stands for gravitational acceleration, and its unit is meter per second square. Force. Now, what do you mean by force? So, it is a push or pull acting on a body which changes or tend to change the state of rest or uniform motion of the body. As per the second law of motion, the force is directly proportional to the acceleration, where F is equal to m into A. The unit of force is Newton. Again, m stands for mass and its unit is kg. A stands for acceleration and its unit is meter per second square. So jointly, F is equal to m into A, or force is equal to kg meter per second square, or it is also known as Newton. The unit of force is Newton. Pressure. Now the pressure is a force exerted by a fluid body. Fluid body means liquid or gaseous. If there is a solid body is there, then it is known as a stress. But if the fluid body is there, then it is known as a pressure. The unit of pressure is Pascal. These are the sum of the conversion of the units related with the pressure. Kilopascal, 10 raised to 3 Pascal. If 1 megapascal is there, then it is 10 raised to 6 Pascal. And if 1 bar is there, so 1 bar is equal to 10 raised to 5 Pascal. The measurement of the pressure is done by the barometer or pressure gauge or manometers. Here is different types of pressures are there: absolute pressure, gauge pressure, vacuum pressure, atmospheric pressure, and absolute zero pressure. Now first of all, absolute pressure. It is a pressure exerted by an atmosphere and it varies place to place, measured from a sea level. The standard atmospheric pressure is 1.01325 bar, and this pressure is measured with the help of barometer. Gauge pressure. The gauge pressure is related to the atmosphere. It is called a gauge pressure and it is generally measured by a pressure gauge. Another is a absolute pressure. It is a pressure measured with reference to the absolute zero pressure, and its pressure is related with the perfect vacuum. So mathematically, absolute pressure is the atmospheric pressure plus gauge pressure. Now, work done or work. Work is said to be done when the force is applied on a body and it travels in the direction of force. It means W is equal to F into D, where D is a displacement, F is a force. The unit of force is Newton and unit of displacement is meter. So the unit of work done is Newton into meter, or it is also known as a joule. Next is power. Power is defined as a rate of doing work or work done per unit time. Mathematically, it is derived by P is equal to W by T, work done per unit time, and the unit of power is watt, kilowatt or joule per second. Another is energy. What is energy? So energy means the capacity of doing work. Energy are of two types: potential energy and kinetic energy. Potential energy, the energy possessed by a body due to its position. For example, a brick is putting on the wall. It is an example of potential energy. Potential energy PE is equal to m into g into h, mass into gravitational acceleration into its height. It is directly proportional to height. If the height changes, the potential energy will also change. Now, kinetic energy. The energy possessed by a body due to its motion. And the example of that is jet of water coming out from the nozzle, or bullet is fired from the gun. Kinetic energy KE is equal to 1/2 mv square. Now, the different thermodynamic systems. First of all, what is system? A system is defined as a quantity of a matter or a region in a space chosen for a study. For example, a quantity of steam or turbine, etc. The mass or a region outside the system is known as surrounding, and the real or imaginary surface which separates the system from surrounding is known as the boundary. Types of system. There are three types of system: open system, closed system and isolated system. Open system. In open system, mass as well as energy both can transfer take place from the system or to the system. Most of the engineering devices are of open system. For example, boiler, turbine, compressor, pump, IC engine and so on. Closed system. In a closed system, only heat transfer takes place, mass cannot transfer from the system. It is known as a closed system. In isolated system, there is no interaction between the system and surrounding. There is no mass, or neither mass nor energy can transfer take place from or to the system. Large example of the isolated system is a universe. For a temporary purpose, the example of the isolated system is a thermos. Heat. Heat is defined as an energy interaction at the system boundary which occurs due to temperature difference only. Heat transfer is written as capital Q. Heat transfer Q is equal to mc delta T. M means mass, C specific heat, delta T change in temperature. Specific heat. It is defined as a heat required to rise the temperature of unit mass by 1 degree Celsius. The heat transfer to the system is considered as a positive heat, and heat transfer from the system is considered as a negative heat. Now, the law of thermodynamics, zeroth law of thermodynamics. Zeroth law of thermodynamics states that if the two bodies A and B are in thermal equilibrium with the third body C, then they both, means A and B, they both are in thermal equilibrium with each other. First law of thermodynamics. First law of thermodynamics states that the energy can neither be created nor be destroyed. It can only transfer from one form to another form, and total mass of the system remains constant. It is also known as the law of energy conservation. Q is equal to W plus delta E, where Q is equal to heat transfer, W is equal to work done, and delta E change in energy. For the thermodynamic purpose, we are using delta U, change in internal energy. Second law of thermodynamics. Second law of thermodynamics has a two statement. First is Clausius statement, and second one is a Kelvin-Planck statement. First one is a Clausius statement. It says that it is impossible to construct a device which transfers the heat from lower temperature to higher temperature without giving any external work. Second is a Kelvin-Planck statement. It says that it is impossible for a device which gives the 100% efficiency. Or another statement is, it is impossible to construct a device which operates on a cycle and produce net work while exchanging the heat with the body at the same temperature. Thank you.